Hi guys, Mrs. Hargrave. Some of you guys had some questions about different kinds of problems from chapter 11 and 12 for your test this Friday. So I am making this video to give you guys a couple of examples. So hopefully you can do them at home and do them on your own on our test. Alright, so let's take a look at this problem that I have for us. What I want you to answer first is what kind of a reaction is this? Okay. The easiest way is to look at your reactants. Okay, you can see that we have oxygen as a reactant. Okay, if oxygen is a reactant, then most likely your reaction is a combustion reaction. Okay, and you can see that your products are CO2 and H2O, so you know that this one for sure is a combustion reaction. Okay, and it's a complete combustion reaction, again, because of these exact products. All right, so let's go ahead and begin balancing this. Write down the elements that you have on each side of the reaction, okay, on your reactant side and your product side. Then go ahead and count each atom of the compounds that we have. Sorry. All right, so we have 2 C's, 6 hydrogens, and 2 oxygens. 1 C, 3 oxygens, I'm going out of order, 2 hydrogens. Okay, and let's just double check. 1, 3, 1, 2. Good. All right, so now, usually I would tell you if an element is by itself, start with that one. However, oxygen is by itself on this side, but on this side it's in 2 places. So it would be easier to either start with your hydrogen or start with your carbon. Okay. And so we're going to go ahead and start with hydrogen. You have a 6 and a 2. What's common between these? Well, if you put a 3 in front of water, then you'll equal 6. Okay, so we're going to start with that. And you can see I'm doing this in pencil, so we can erase, and we will have to erase. Alright, so now I have 6 hydrogens and 3 plus 2, 5 oxygens. Okay, so now, again, I don't have to do anything to this side because I want to get 2 carbons. So I'm going to put a 2 here, and now I have 2 carbons, 4 plus 3, 7 oxygens. Okay, our 2, our 6, everything looks happy except for oxygen. We cannot put decimal points. It has to be whole number coefficients, unfortunately. So what we need to do is change these numbers, okay? And so a good indicator or a good place to start maybe would be to double everything, okay? I have done this problem, so I know that's what we need to do, but we can go back and play around with things. So go back to hydrogen. Another coefficient that would give us a 6 and a 12, so we have 3 will give us 6 and 6 on both sides, but that's not enough, and we want this to be even. So let's put a 4 in, because 4 is an even number and it's bigger than 3. Okay, so now I have 8 hydrogen and 4 plus 4, 8 oxygens. Okay, but because I've changed the hydrogens on this side, I have to do that to this side. Okay, and there's no way to get 8. So I need a number that is higher than 6. And so 6 and 2, I can use a 2 in front of here and then make this one, make both sides have 12 hydrogens. So we're going to do that. So a 2, and that gives me 4 carbons now, 12 hydrogens, and oxygen just stays the same. Now we look at the other side and we have to change it. So we can start either way. Okay, I need 4 carbons, so I've got to put a 4 here. So now I have 4, and I have 8. We'll get to it because we have to change hydrogen. Sorry, paper's going all over the place. So to get 12 hydrogens, I put a 6 in front of water. And so now I have 12 hydrogens, 6 plus 8, 14 oxygens. Now I have an even number that I can put a number in front of our O2 and balance our oxygens. So what do 2 and 4, or 14 divided by 2, I put a 7 in front of oxygen, and that should give me 14. So let's double check. 2 times 2, 4. 2 times 6, 12, and 7 times 2 is, 14. Let's check the other side. 4 times 1, 4. 6 times 2, 12. Wow, that's a bad 12. 12. And then you have 6 plus 8, 14. So my balanced equation, we'll rewrite it nice and neat, because lots of erasing and stuff can cloud your answer, and I need to see your answer to be able to give you a correct grade or an accurate grade. And this is our balanced equation, and I'll move that up because my head's in the way. Next problem. So here we have more of our chapter 12 problems with a little bit of 11 in there. So we start with lithium. Whoops, I only put lithium. Lithium hydroxide decomposes into lithium oxide and water. So first off, write your skeleton equation, so that way we can do part A, write a balanced equation, and then from that we can do B, figure out how much water would be formed if we have 12.6 grams of lithium hydroxide in the beginning. The wording of this equation tells you what kind of a reaction it is. You have one reactant, which right there should tell you decomposition, but then it says decomposes. It breaks down into lithium oxide and water. So you know it is a decomposition reaction. So let's go ahead. We've got lithium, looking up at the periodic table, and its charge is a +1. And then we have hydroxide, which is a -1. And this decomposes into lithium oxide, so again +1, oxygen's a -2, plus water, H, and hopefully you know the formula for water. Alright, if not, you have a +1 and a -2, crisscross, good. And then we need to do the same for all of our other parts of our equation. So again, crisscross, you'll have 2 lithiums for 1 oxygen, and here they're both the same, so it can remain just as it is. Okay, so we'll move it up. So writing a balanced equation. So for A, we've got to balance this. And we can actually just put that A right there. So let's write down your elements on both sides and count the atoms. So I have 1, 1, 1. Here I have 2, I have 2, and I have 2. Okay, this one is pretty easy. Seeing that all of these are 1 and in one compound, and these are all 2s, I can just put a 2 in front of here. I now have 2 lithiums, 2 oxygens, and 2 hydrogens, and I'm balanced. So let's go ahead and write that a little bit lower. So you have 2 lithium hydroxides, whoops, every time, yields lithium 2O plus H2O. Okay, now our second equation says that our given, always write your given, is 12.6 grams of lithium oxide. And I want to know, I need to find grams of water. Okay, so again, begin with what you're given. So we've got 12.6 grams of the lithium oxide. And then not using the magic number. If you understand and get the same answer, then you can use the magic number. Otherwise, use this method. So I need to have grams of lithium oxide, and I need to convert this to moles. So I know 1 mole of any compound equals its molar mass. So lithium, let's see, is 6.9, so we'll say 7. 7 times 2, 14, and oxygen is 16, so that would give us 30. And I can double check on the calculator. 14 plus 16. Yep, we're correct. So my grams cancel out. If you do this, cancel out your units each time, you know what your next step will be. So now I need to go from moles of lithium oxide to moles of water, because that's what I need to find. So let's go ahead. So I have moles, lithium oxide, and moles of water. So let's look up at our equation to find our mole ratio. How many moles in this equation, yes, are how many moles of lithium oxide? And I see I only have one because there's just one. And then how many moles of water? And again, that is 1. And so now I can cancel out my moles. And I'm at least in the right unit. I have water, which is good, but I want grams of water. So one more step, cancel out moles. And again, I know 1 mole of water will give me the molar mass of water. Pretend that looks like it now. So moles cancel out, and I will have grams. But how many grams? Oxygen is 16, hydrogen's 1. We have 2 hydrogens, so 1 times 2, 2, plus 16, 18. Okay, there's nothing I can cancel out. So then we take our calculator, and I'll see if I can plug this in for you so you can see what I'm doing exactly. 12.6. And I'm going to multiply that by everything in the top, times 1 times 1. I don't need to do that. Times 18. And I want to push the equal sign so that everything is divided by everything on the bottom, which is 30, 1, and 1. So just 30. Oops. Sorry. Let's redo that. So you have your 12.6 times 18 equal sign divided by 30. And your answer is 7.56 grams of water. Hope that helps. So that's grams to grams. Time for just a little bit more. So we're going to use the same reaction and the same given for lithium dioxide, but now I know that I have lithium hydroxide. So these are my givens. Now I need to do step 1. So step 1 is to figure out if I already had this in moles, so I have grams. So now I know I don't have moles. I need to convert it to moles. So there is step 1. Okay, you write the grams of each compound, and then you divide it by its molar mass, okay? And we already figured out the 30 earlier for lithium oxide, and there's 1 mole, and that's how many grams. And then lithium is 7, oxygen is 16, hydrogen is 1, add those up, and you should get 24, okay? So when you solve those, go ahead and solve them. You can pause this. But when you solve them, you should get these 2 answers for moles. I'm going to lift it up because my head's in the way. Okay, these are the moles that we have. So now what I need to do is see what is my limiting reagent. And that reagent is behind my head again. What is my limiting reagent? So again, I need to take my moles, and then I need to multiply them by the mole ratio. So remember we have the 2 lithium hydroxide yields lithium oxide plus water. Okay, so lithium oxide, there's only 1 in our equation. So every time you see that, you can put a 1. Lithium hydroxide has 2, so every time you see that, you'll put a 2. So these equations are just flip-flopped. And then you solve those, and you should get, and I'll lift it up, and you should get these 2 numbers. Okay, so you have 0.84 and 0.48, and these are moles of these. So if these are the moles that we have, okay, and this is what we need, so I have 0.42 moles, okay, is that we can even